Let's see, everybody. So let us discuss about batteries. It's a very small part of this syllabus. Batteries mainly we have primary and secondary. Primary kind. Primary is something only used once, and cannot be cannot be recharged. So if you can't recharge it, we call it as primary battery. So one of the most commonly used primary battery is dry cell. Dry cell, okay? Dry cell, which is also known as Leclanche shell. Leclanche cell, okay? Here, I'm sure you must have read in the NCRT book there. So there we have, graphite rod, graphite rod. Along with, we have some zinc here. Along with we have some manganese here, MnO2, plus some more carbon and NH4Cl paste. And then this is covered by top of it with a zinc cell, so which is a zinc metal. Okay, this is typically how the dry cell would look like. And as an anode reaction, if you notice, zinc is getting oxidized. Zinc is getting oxidized, so Zn2 plus 2 electrons, while at cathode, if you notice, it is becoming MnO2 plus NH4 plus an electron to convert into MnO to OH plus NH3. So if you notice the oxidation state from +4, it is changing to +3 oxidation state. Okay. And Zn2 plus eventually will combine with ammonia that has been released and convert itself into a complex. So this is the final form of zinc which you will notice. Okay. If you write the Q value here, so Q would be equal to Zn2 plus concentration, correct? Zn2 plus concentration. And this I have to multiply with 2 here. So therefore that will be equal to, and this is also a solid form. This is also a solid form. So it will not remain anything in this particular group. So Zn2 plus into 2 moles of ammonia, correct? And you notice that this zinc plus ammonia is combined to form in this particular manner, isn't it? So uh, if you take this concentration, it will be NH3 concentration divided by NH4 plus concentration. Okay, this is solid, this is solid, this is solid. So only thing that is left is ammonia and NH4 plus. And well, you notice this ammonia also, if you check it out, it will be combined with zinc to form into this form, this particular manner. So we can again write this form here. But one thing is for sure that Q is proportional to zinc 2 plus concentration. Okay. So which means as the zinc gets completely consumed, you would notice that there is a decrease in the E cell value. Okay. So E cell, which is equal to E naught cell minus 0.0591 by N log of Q. So the Q value decreases as zinc value will decrease. Clear? So what you would notice here is Zn NH4 plus is also NH4 plus is also getting decreased here, isn't it? So if you compare the amount of loss of this one, this is square, sorry. Okay. So the amount of loss of NH4 Zn2 plus compared to NH4 plus, this decrement is much more compared to Zn2 plus. So overall, Q remains positive over time. I mean greater than 1 over time. So if it is greater than 1, then E naught E cell value will keep decreasing. the maximum amount of E naught value that it can create is around 1.5 volts. Okay. And as it will reach to a steady state and it will give around 1.5 volts for a long time. And if you notice from the time period here, voltage versus time, it will keep giving 1.5 initially and then starting decay and then start to decay. Well, it may be linear or may not be, but this is how it will happen. So over the time, it will start decreasing. Correct? This is about dry cell. Okay. Next one is about mercury cell. Mercury cell. Mercury cell is suitable for devices having hearing aids or uh, watches, correct? So in such cases, we will use mercury cell instead. Okay. This will contain, in the anode part, you will see instead of having only mercury, we'll take zinc mercury amalgam and we will have KOH added into it. Okay, a KOH, concentrated KOH will be present. In the presence of KOH, zinc will get oxidized to form ZnO and H2O plus 2 electrons plus Hg liquid. This is what you will see at anode part. Cathode part, you will notice it as HgO, okay, plus H2O plus 2 electrons gives Hg liquid plus 2 OH minus, okay. So if I write the overall reaction here, the 2OH is getting cancelled. All I have is zinc mercury amalgam plus HgO, which is giving ZnO plus Hg liquid. So in a way, Q is always being 1. So you will see a constant voltage is being generated. Okay. So E value will be almost equal to E naught value, which is equal to 1.35 volts. So especially when you want to maintain the accuracy, right? And that is an important part. Then mercury cells are being used here. Correct? These are called alkaline batteries. Any batteries which are using base is always known as alkaline batteries. And they last longer. Alkaline batteries usually last longer. Okay. Next is secondary cells. Okay. Secondary cell is something which can be recharged by passing current, Okay. See, if you recall Daniel cell here, in Daniel cell, we learned that this is how the salt bridge would be. And here are the electrodes. And the flow of current would go, flow of electrons will go in this direction. This is the flow of electrons. Okay. Flow of electrons will go in this direction, while the current will go in this direction. Okay. This is the voltmeter. Imagine externally, I have one more source here, like this, and it is connected here. So now the flow of electrons is coming this way, okay, which is opposing the flow of electrons, okay. So if I call this as E external, okay, or this is a voltage which you can get, so I'll write it as V external. So there are three conditions I can get. One, E cell which we are creating could be greater than V external, or second, E cell could be less than V external, and third would be E cell is equal to V external. So if E cell is greater than V external, then the flow will still be from here to here. So electron will flow in the natural way from zinc to copper, but overall overall voltage decreases. Okay, flow remains same. Flow remains same. Sorry. Next, if V external is greater than E cell, then cell cell convention will be reversed. Cell convention will be reversed, reversed, and and zinc get zinc get reduced and copper get oxidized. And this is a situation called recharge. So that means if you have an external voltage greater than that of the E cell, then the recharge could happen. If E cell is equal to V cell, then it is called the cell is at equilibrium. The cell is at equilibrium. Okay. So secondary cell is a situation where the V external is greater than that of V E cell. Okay. Well, there are many secondary cells, but one important cell which you need to learn is lead storage cell. Okay. Lead storage is a cell containing sulfuric acid. Here you'll have 38% by weight of H2SO4. So enough concentrated here. We will have six anodes here. Like this, we will have six anodes, 4, 5, and 6. And six cathodes here. 2, 3, 4, 5, 6. Okay. And each cell, if this is the positive part and this is the negative part here, then each cell, if let's say this is the anode part, this is anode and this is cathode. So it is a cell connected in series. So you can see this is one cell, this is one cell, this is one cell, this is one cell, like this. So each cell will develop a voltage of around 2 volts. Okay. Okay, E cell of around 2 volts. So the series of these cells is what we call it as the lead storage battery. Correct? Typically, what would happen here is at anode will have a lead. This part will be lead, while this will have a lead dioxide coating. Okay. So at anode, what do we have? Anode reaction would be lead Pb reacting with SO4 2 minus in the solution present, converting into PbSO4 solid plus 2 electrons. While cathode will have PbO2 solid plus SO4 2 minus aqueous plus 4H plus, and consuming these two electrons, it will also become PbSO4 plus 2H2 liquid. Okay. Overall reaction, if you notice, so that will be equal to PbS plus PbO2 solid, okay, plus 2H2SO4. This we can write it as 2H2SO4, which is giving 2PbSO4 plus 2H2 liquid. So Q will be simply 1 by H2SO4 concentration whole square. Correct? So as long as you have high concentration of H2SO4, Q value will be less. And Q value is less means E cell will be better. Okay. So E cell will be equal to E naught minus Q 0.0591 by 2 log of 1 by H2SO4 whole square. Correct? So higher the concentration of H2SO4, Q will be lesser than 1 and E cell will be greater than E. And generally the E naught value which it will produce is around 2 volts. Correct? So each cell will produce 2 volts. So industry standard is that every car battery should have at least 12 volts. So that's why the car battery, that is, I mean, the entire setup in the car where electricity, I mean, where the current is required is based on the cell which is basically designed of 12 volts. Okay. So I hope all of you got this. We also discussed the other day that the equivalent weight of H2SO4 in this case will be equal to molecular weight by 1. Okay. So valency factor in this case is 1. So this is a basic information, everybody, that you need to remember when it comes to lead storage battery. Okay. Next. Another secondary cell which you will see is about cadmium cell. So here basically cadmium CD solid, with 2 electrons, sorry, CD solid with 2 moles of OH minus aqueous will give us CDO, CDO plus H2O liquid plus 2 electrons. This is what is happening at anode. When it comes to cathode, it is nickel OH thrice, correct? Nickel OH thrice plus H2O will convert into um, plus 2 electrons, plus 2 electrons will convert into NiOH twice precipitate, right? And that's it, plus another H2O. Okay. So if you write the overall reaction would have cadmium solid plus nickel OH thrice. Sorry, here it is. Here it is 2 moles of OH minus. What to write that? Yeah. Okay. Hmm. So nickel NO3 minus. This is giving CDO solid plus 2 moles of NiOH twice solid plus H2O liquid. Well, this will also create a voltage of around 2 volts. Right? So, in fact, this is much better than nickel cadmium cell is much better than lead storage battery in terms of duration. It will last for a longer time, but relatively very costly. Okay? So, as a commercially viable, if you notice, cell lead storage battery is better. Okay. Last thing we need to understand is about fuel cells. Fuel cells. Okay. Fuel cell, mainly hydrogen cell, is one of the most important one which can be used. Okay. Mainly, we call that galvanic cells, which can be run using hydrogen, methane, methanol, ethanol. Got it? These are called fuel cells. These are called fuel cells. Correct? Now, one of the most successfully used fuel cell is this one, where we have, H2 gas is being passed from one end and O2 gas is passed from the other end, like this. And here we have an anode, which is graphite rod, which is impregnated with, which means it is made small holes and it is mixed with, KOH. So you'll have some amount of KOH present in it. Clear? And this part of the solution also is completely having aqueous KOH part. So, how does the mechanism work here? See, most of the time here we can also use for adsorption. We can either use a graphite rod or we can use a metals like platinum, correct? Depending upon how much is the requirement here. We can use this as impregnated platinum or palladium, that can be used. Next, if you notice the anode reaction here, at anode, we are seeing that H2 gas plus 4OH minus aqueous would give us 4H2O liquid plus 4 electrons. While at cathode, if you notice, this would be O2 gas plus 2 H2O liquid plus 4 electrons will give us 4 OH minus. So overall reaction, if you notice, 2 moles of H2 gas plus O2 gas is giving 2 moles of H2O liquid. Okay. Now, which means Q value only depends upon the pressure of H2 whole square into pressure of O2 whole. So if you have as much compressed gas as possible, lower the Q value, and lower the Q value, better the uh, E cell value. So E cell value will be equal to E naught cell minus 0.0591 by 2 log of 1 by pressure of H2 square and pressure of O2. Okay. So whatever the pressure which is developed, higher the pressure, better is the E cell value. Okay. See, generally any batteries, efficiency wise, if you notice, efficiency is what? Delta G naught value by delta H naught value. This value is very close to 40%. Correct? Percentage efficiency is around 40% for most batteries. For most batteries. Clear? While for fuel cell, the percentage efficiency is around 70%. Right? So keep this in mind. So the percentage efficiency of the cells is also fuel cell is also very high. So the loss of any energy in terms of heat or in terms of resistance, that is less for it. So fuel cell is more efficient that way, and it is very environmental friendly as well. Yeah. So I think you guys got this point. Right? Rest of the part that includes corrosion, I think we have already discussed. So this is the main part in which you need to revise it once, everybody. I'm sure all of you must have gone through it, but nevertheless, just check it. What are the important points you need to know? Okay, right. Going back to the questions here now. So let us see what are the types of questions that could be asked from here. See, let us go with the latest question first. How the latest questions have been asked. Based on that, we can discuss. First, we'll discuss all the 2024 questions. I'll show you the type. At least you'll get an idea, like what is the type of questions that are being asked, in the recent times. Okay. See, first one. See, first one. One of the commonly used electrode is calomel electrode. Under which of the following categories calomel electrode comes? Okay. I told you that calomel electrode is a cell where you have Hg2Cl2, correct? Which is combined with KCl to reduce itself into Hg, correct? So what do we call it? We call it as a metal insoluble salt anion electrode. Okay. So what is the first learning you should know, everybody? That you need to revise the types of cells, types of electrodes we discussed. Okay, gas electrode, metal electrode, redox electrode, correct? Which is oxidation reduction electrode. So whatever that is there in the booklet, in the class notes, as well as what we discussed, just revise. Okay. See, next question. There is a representation of the cell given, E naught values are given. Which of the following is correct? What will be the value of E cell and whether it is spontaneous in which direction? Okay, that is what is the question is. Correct. So if you notice the reaction here, M plus X is giving M2 plus X2 minus. So these two are solid states. These two are liquid state, gaseous states, correct? So in that case, if E naught value is given and E naught value is given here, so what we can say, whether this reaction would be spontaneous or not. That's what we need to see. Check. First, E naught cell value will be equal to reduction, which is reduction. This one is reduction. And this one is oxidation. This one is undergoing oxidation, but this is a reduction value. So therefore, 0.34 minus 0.46, which is minus 0.12 volts. Okay. So at a standard conditions, this is not possible. Okay. Maybe at a different concentrations, this cell could become spontaneous. Okay. Clear everyone? So we can say that the reverse, if you put it, it will be spontaneous at standard conditions. Now please go through the options and understand. One second. Divij, I'll just come back and discuss it. Just give me a minute. Let me finish this. Yeah. So from here, you can clearly make out that, the reverse reaction is more spontaneous at standard conditions. Neither this is the value, this is the value because I do not know any concentration terms. And this is definitely not correct at any concentration point. So therefore, what is this one? C is more appropriate option. Okay. Like how can an electrochemical cell can be converted into an electrolysis cell? Okay. Applying an external opposite force. Just now we have discussed. Okay. When you have E external, the cell will become reversed. Cell is reversed means what? Then you are using electricity to make that non-spontaneous reaction. And this is correct. Okay. Next. Reaction. This reaction is given. How do we represent it? Okay. So remember the representation is very important. First, notice whether what are the options given here. First, H2 is getting oxidized. Realize that. Then AgCl is getting reduced to Ag. Okay. So I need to first represent the what do you say, inert electrode, then a gas which is converting into H plus. In this case, this is HCl given. So which means HCl must be a common part for both of them. Okay. So HCl aqueous, then AgCl paste is present, which is getting reduced to become Ag. Got it? So this option is more appropriate. Clear everybody? That's what you need to figure out. Okay. Next. Let us go to the next types where in recent times the questions have been asked. In non-stick question, check out. What is the question that is asked from non-stick? The hydrogen electrode is dipped in the pH is equal to 3 at 25 degrees. The potential of electrode will be how much? Okay. So again, this is very standard question. You should be able to get this. See, what is being asked is E cell is equal to E naught cell. E naught cell is 0 minus 0.0591 by 2 log of Q. So what will be Q here, beta? Because it is about the hydrogen electrode is dipped in a solution of pH 3. The potential of the electrode will be how much? Okay. So here I can say that 2H plus 2 electrons is giving out to be H2 gas. Here, giving out to be H2 gas. Then what will be the value here? So I can write it as pressure of H2 divided by H plus concentration whole square. So that is equal to minus 0.06 by 2 approximately into log of pressure. If nothing is given, you'll always take it as 1 by H plus concentration. H plus concentration is 10 raised to power of minus 3 whole square. Correct? So that would be equal to minus 0.06 by 2 into this will come up. So log of 10 raised to power of 6. So 6 is what we will get. So 3 here. So it will be minus 0.18. So which is 18 into 10 raised to power of minus 2. Okay. See, smartly didn't mention whether it is reduction or oxidation, but you have to always figure out, think in terms of reduction and do it. Even if you put oxidation also, no problem. Just that you will get, instead of minus 18, you'll get plus 18. But the answer would remain the same. Okay. See the next question. The potential for the given half cell is this much, right? I think this is the same thing. Sorry. Oh, now this time the pressure has changed. But same question, exactly same question in a different shift, but pressure has been changed. That's it. Earlier we assumed it to be 1 atm pressure. Now this is 2 atm pressure. That's it. Okay, nothing else. Everything else is same. So I got 26 now. MnO4 plus H plus giving in the presence of oxalic acid gives Mn plus 2 and CO2. The standard reduction potential for E naught reduction is how much? Okay. Now, manganese is getting reduced, carbon dioxide is getting oxidized. Okay. So first we will try to figure out what is the value of E naught cell. Okay. So you can see E naught cell value, E naught cell value will be equal to 0.49 because this is the reduction given. The oxidation will be minus will become plus. So minus 0.4 plus 1.51, which is 2 volts. So E naught cell is 2 volts. And if E naught cell is given, and at equilibrium E cell will be equal to 0. So that is equal to E naught cell. E naught cell is 2 volts minus 0.0591 by how many electrons are transferred? Everybody. Okay. First, for that, the balanced reaction is what we need to write. So from here, 5 electrons. So this will be 2 and 5. And for that, if you notice the number of water molecules here, you can see 8, 4 to the 8, 5 4 to the 20. So 28 amount of oxygens are present here. So here we will have 10. So 20 are here. So which means I need to have 8 here. And out of that, 10 is already present here. So out of 16, 10 is already present here. So we need to have 6 H plus. Correct. Okay. Check out the balanced form. So we just have to notice the balanced form here. Okay. So as I he didn't ask that also. We just need to know the number of electrons transferred. That's all. If the number of electrons transferred is known, K value is it because this is at equilibrium and we just need to figure out what is the K equilibrium. That's it. So you don't have to worry about balancing this. So simply now E cell will be E naught cell will be equal to E naught cell this 2 minus this one divided by 10 electrons transferred into log of K equilibrium. Okay, log of K equilibrium. So how much will be the value here now? So K equilibrium. So if I take it to the other, it's a 0.06 by 10 log of K equilibrium is equal to 2. Okay. So from here we are getting K equilibrium is equal to something like 20 divided by 0.06. This is the value you will get. Okay. That he represented in 10 raised to power of x. There was actually some value given here in this question. I forgot, but I remember that there was some value for this log to help out that was given. Okay. Yeah. So from there you could figure out what is the K equilibrium value. Okay. Just learn to balance it, how to balance the equation. If you know that, that is it. Next. What pressure of H2 would be required to make EMF of electrode potential zero in pure water? Okay. Have you noticed one thing? They have been constantly asking hydrogen electrode. Okay. Here and there, again, they'll keep moving around and ask the same hydrogen electrode. Got it? So see how we can figure out. The reduction potential is 2H plus 2 electrons is giving H2. Got it? If that is the case, now E is equal to E naught cell is 0. So minus 0.0591 by 2 log of pressure of H2. That is what we need to calculate divided by In pure water, how much will be the H plus concentration? 10 raised to power of minus 7 whole square. Correct? So substituting this value, and E value is also required to give 0. Okay, E value is also given 0. So if this is 0, so pH2 log of this entire thing is 1. So pressure of H2 by 10 raised to power of minus 14 is equal to 1. So pressure of H2 is equal to 10 raised to power of minus 14. So that is answer A. Okay, clear? So next, thallium to thallium plus and copper to plus to copper, right? So if you notice that thallium to thallium plus and copper to plus to copper to plus is given, and it is increasing concentration of Tl plus. Okay, so of course it will be increasing the concentration of Tl plus ions over time. Okay, and it could be what? This is the concentration of copper 2 plus ions. Increasing concentration of Tl plus and Cu2 plus ions. Decreasing concentration of this one and increasing concentration of CO2 plus ions. See, E cell is given spontaneous. E cell is being positive, correct? If it is positive, be increased by. How do we increase it? See, E cell value is equal to E naught cell minus 0.0591 by N. In this case, it is 2 log of TL plus concentration by CO2 plus concentration. Correct? This is the concentration term which you have. And TL plus whole square. Okay. So now if at all I have to increase this value, I need to make sure this value is decreased. For decreasing this value, I have to increase the copper 2 plus concentration and decrease TL plus concentration. So increasing TL plus concentration doesn't work. Increasing both doesn't work. Decreasing both doesn't work. Increasing CO2 plus concentration works. Okay. It is just to show which will give a better change or better increase in E cell value. This is also from 24. Chalo. The standard reduction potential for the half cells are given here. Consider the given electrode, the number of metals which can be oxidized by Cr2O7. This was a simple integer type question given. See, if this 1.33 is the reduction potential for chromium, you need to notice the other reduction potential should be less than this to reduce that, isn't it? So that the others can get oxidized and chromate can get reduced. So obviously this value is quite less, this value is less, this value is less, this value is not. So which means how many metals? How many metals? Iron, nickel, silver. All three can be oxidized and dichromate can be reduced. So therefore, how many? Three in this case. Got it? Next. Right. So these are the types that were asked from Nernst equation. Coming to the next part here. Yeah. Conductance and conductivity cells. Okay. So check out conductance and conductivity cells. What are the types of questions asked? The first one. The mass of silver displaced by a quantity of electricity which displaces this much O2 will be equal to how much? Okay. Displaces this much amount of O2 will be equal to how much? Okay. See, O2 to displace here, displaced by quantity of electricity, which displaces this much of O2 at STP will be how much? Okay, it is about comparing the number of Faradays that is required. Okay, so first of all, number of moles, check out. Number of moles will be equal to 5600 by 22400. Got it? 5600 by 2 this much. Okay. Right. So in this case, if you compare here, now what is a valency factor of O2? Because you know that the amount deposited V2, if you notice the number of moles. So let me show you the formula, then it will be more easier. W is equal to E by F into Q. This is what we know, correct? Z into Q. Z I am writing it as E by F. Well, you know that W can also be written as number of moles into molecular mass, which is equal to E by F into Q. And molecular weight can also be written as E into valency factor, that is equal to E by F into Q. Correct? So therefore, E will get cancelled. Number of moles is equal to Q by valency factor into F. So have you noticed that number of moles is always inversely proportional to valency factor for a same charge? So that is why number of moles of silver by number of moles of O2 will be equal to valency factor of O2 divided by valency factor of silver. This is what you can use, correct? So number of moles can also be written in terms of mass. So mass of weight by molar mass. So weight by molar mass, which is 108, into weight into number of moles of O2 we already calculate. That is 56 by 224. That is equal to valency factor of O2 is 4. Silver is 1. So calculate W. Understood now? That's how you calculate W part. Right? That is coming approximately 108. Okay. So it is for 1 mole. Good question. Very simple way of asking. But I'm sure you should be able to relate it, making it easy. Okay. Next. The mass of zinc produced by the electrolysis of zinc sulfate solution with steady current of this much for 15 minutes is how much? Okay. Right. Okay. So, how much is the mass produced? W is equal to E by F into T. So, equivalent mass of zinc would be 65.4 by 2 into Faraday is 96500 into I into T. I is 0.015 into time. Time is 15 into 60. Here, this is what we need to write. So this is coming out to be 46 into 10 raised to power of minus 4. Okay, so the answer is 46. That's it. Next. A constant current was passed through a solution of AuCl4 ion between gold electrodes. After a period 10 minutes, the increase in mass of the cathode was this much. The total charge passed through the solution is how much? Okay. Again, it is of a similar case only, but so we just need to figure out how much is the gold that is getting deposited. AuCl4 minus, which means it is at plus 3. So plus 3 electrons will help it to deposit as gold. So valency factor is 3 here. So since valency factor is 3, uh, weight, here we need to find out Q. So W is equal to E by F into Q. So Q will be equal to F into W by E. So 96500 into weight deposited is 1.314 divided by equivalent mass. Equivalent mass is 197 by 3. That's it. So you calculate that, you are getting it as 2 into 10 raised to power of minus 2 Faraday. Sorry. Keep this in F only because it's given in Faraday. Okay. So this value is coming out to be 2 into 10 raised to power of minus 2 in Faraday. Okay. So about 64. Identify the factor from the following that does not affect electrolytic conductance of solution. Okay, that does not affect the electrolytic conductance of solution. First, the nature of electrolyte added. Yes, nature of electrolyte added will always, affect the electrolytic conductance. Next, the nature of electrode used. Nature of electrode used is not something which will affect. See, conductance, electrical conductance, electrolytic conductance will be affected based on what is the dimensions of that electrode, but not what is the properties of the electrode. It will be depending on the dimensions of the electrode. Next, concentration of the electrode, yes. Nature of the solvent, yes. These are all the important dependencies for conductance, except for P. 1 Faraday electricity liberates this much of copper. I'm sure you guys can do that. The values of conductive, some material is given, right? The number of conductors among the material is what? Which one? Okay. I think this one is good one. Check it out, everybody. See, here these are the values given. Okay. See, usually we know that if the values are somewhere between 10 raised to power of 3, that is conductors, correct? And if it is lying between something as 10 raised to power of minus 3 to 10 raised to power of 3, sorry, 10 raised to power of minus 5 towards 10 raised to power of minus 3, that is semiconductors. If it is very less, 10 raised to power of minus 8 and less, correct? Then that is going to be insulators. Okay. So out of these materials which you have various conductance, check out which one are conductors here. This is conductor. This is also a conductor. This is also a conductor, isn't it? And where is it? That's it. This one. This one is also conductor. So how many we got? Four. So four are the conductors. Correct? So this is up to minus two minus. Yeah. Got it? So keep this in mind in what is the range of conductors, semiconductors, and insulators. Next, the amount of electricity in coulombs required for the oxidation of H2O to O2. So I'm sure you know that. Just remember the reaction, everybody. Okay. H2O, we have to oxidize it. So basically, we'll get this as 4H plus O2 plus 4 electrons, which means for 4 Faraday, 1 mole is 1 mole of O2 is coming. So based on that, find out what is the electricity required. Okay. For 1 mole, how much it is? For 1 mole, you require, you'll get only half mole of O2 here. Okay. So half mole of O2 means 2 Faraday charge. Next. For a strong electrolyte, a plot of molar conductivity against the concentration is straight line with a negative slope. The correct units for the slope is which one? Oh, good one. Check. We know that for strong electrolytes here, we learned that lambda m versus under root of c. We will get this formula. Lambda m is equal to lambda m naught minus a into under root of c. The Behackel's equation. Now we need to figure out what is the correct units of slope. What is the slope here, beta? Slope is A here. So what will be the units of A? The units of A will be A. This entire thing should be same as the units of uh, conductance. So molar conductance. Molar conductance is Simon centimeter square and mole inverse. Okay, that is equal to A into root of concentration. Root of concentration means it has to be mole per liter. Mole per liter under root of half. Now liter can be written in terms of centimeter cube. Right? So I'll write down that A is equal to Simon centimeter square mole inverse divided by mole raised to power of half, mole raised to power of half into this liter will come out. Liter can be written as centimeter cube whole raised to power of half. Okay, that will be whole raised to power of half. So from there we can write this as, now you can notice that we will get Simon centimeter square. Acha, you don't have to change it in liters because answer given already is in liters. So sorry, don't change that. Liter into half. So mole will become, if this half will come up, it will become minus 3 by 2. So which one is matching? A is matching. Okay. Next. Molar ionic conductivities of divalent cation and anion are given. The molar conductivity of solution of an electrolyte with the above cation and anion will be molar conductance of solution of this one with the above cation and anion will be how much? Okay. See, it is a divalent cation and an anion. Okay, divalent cation and an anion. See, if it is divalent cation and an anion, which means uh, solution will be cation. So I think yeah, because since he is not given, I would take this as divalent cation is something like Mg2 plus and anion is like O2 minus or something. Correct? Because he didn't give that this is also this is monoanion, so I'm taking the same thing as dianion, dication and divalent cation and divalent anion. In that case, it has to be 57. This has to be 73. So therefore, lambda naught of MgO will be equal to lambda naught of Mg2 plus lambda naught of O2 minus. So that will be equal to 57 plus 73. Correct? 57 plus 73. That is around 130. Okay. Check out 17. The quantity of silver deposited when 1 coulomb charge is passed through AgNO3 solution. Okay. So I think this is something which is straightforward. I'm sure you should be able to do it. Okay. Next, check out this one. A conductivity cell with two electrodes. Okay. Dark side, two electrodes. Right. So this is the dark side which we are talking about. Are half filled with infinitely dilute aqueous solution of weak electrolyte. If volume is doubled by adding more water at constant temperature, what will happen to molar conductivity of the cell? Okay, molar conductivity of the cell. Okay, he asked in a very tricky way. Check it out. Usually, what we say, everybody listen. Usually, what we say is that on dilution, molar conductance will increase. Okay, on dilution, molar conductance will increase. But here, he made it very tricky by putting the idea that already it is at an infinite dilution, which means lambda m value is same as lambda m infinity, which is maximum. This is the maximum which has already occurred. Now, whether you increase the volume, double, triple, you make any amount of volume, will it impact the molar conductance of the solution? No. So I think that is what he's trying to check out. Any option here? Yeah. Remains same or can be measured or cannot be measured accurately. Correct? Because it is already at a maximum. It is not like this is going to increase or decrease any further. Correct? Next. Molar conductance for electrolytes A and B are plotted. Electrolytes A and B respectively are. You know that A is for weak electrolyte, B is for strong electrolyte. Got it? So which is option C. Okay. Next, which of the following is correct equation to show the change in molar conductance with respect to concentration for weak electrolyte if the symbol carries their usual meaning? Okay, the symbol carries their usual meaning. Right? Okay, this is a good question. See, this was asked in JE Advance also. Earlier, it was asked in JE Advance in a similar way, but not exact straight equation, but the idea was exactly same. See, if I take any weak acid, okay, I'm taking that as an example. So I can write this as C into 1 minus alpha, C naught alpha, and C naught alpha. Correct? So from there, I can write K is equal to C naught alpha square by 1 minus alpha. And you know that alpha is equal to lambda m by lambda m infinity. Just substitute that values here. So I'll get this as Ka is equal to C naught into lambda m by lambda m infinity whole square minus 1 by lambda m infinity whole. That's it. Okay. Now, if you adjust this entire thing and make this equation such a way, if you pull everything on one particular direction here, best thing is you multiply everything by lambda m and lambda m infinity. So then lambda m infinity will get cancelled. So you will be left out with this equation. That's it. Okay. This is the equation you'll be left out. Clear? So it was a good question, guys. Check it. So I hope last year, majorly what type of questions that have been asked, you must have got an idea, correct? That will give you a input. Now, let me show you one thing. In 2023 also, number of questions that were only related to, electrical conductance, right? Sorry, conductometric titrations as well as the coal rush law are so many questions. You can see from here onwards, 74, 75, 76, 77, 78, 79. Okay. And lot of them from here, 81, 82. So lot of questions from 84 onwards, right? Lot of questions were asked on a similar lines, correct? In 23 onwards. Okay. This is up to 23, up to 80. Okay. Right. Next. Right. Let us see batteries and fuels. What are the types of questions that were asked 24 as well as how it is being asked in 23. Okay. First, the metals that are employed in the battery industries are okay. Which are the metals that are usually employed in the battery industries? Okay. Iron is mainly for corrosion, so that is not used as a battery here. Manganese is used in dry cell. Nickel is also used in, we have seen secondary cell here. Clear? Uh, Chromium has not been used. Cadmium is being used. So B, C, and E. B, C, and E. Okay. So I hope all of you got this here. So remember which cases what is the case. Next. Fuel cell using hydrogen and oxygen fuels have. Okay. Has been used in spaceship. That is true. Have an efficiency 40%. That is incorrect. 70%. We discussed this. Correct. Would have around 70%. So B is incorrect. Uses aluminum as catalyst? No, platinum as catalyst. Platinum and it is eco-friendly. Yes, it is actually a type of galvanic cell. Yes. Okay. So ADE. Check out for ADE. ADE. That is yes. Is given. Next. The reaction at cathode in the cells commonly used in the clocks involves manganese changing from +4 to +3. Correct. So reduction of manganese. That is from MnO2 changing to MnOOH, right? Next. So about this question, Leclanche shell, right? 120 Leclanche shell. Leclanche shell will have an oxidation of this one, so which is more matching with 4. Nickel cadmium cell. Nickel cadmium cell will have, which is a rechargeable cell. We have checked it out earlier. Fuel cell converts the energy combustion into electrical energy. Okay, so that is correct. H2 overall is it is a combustion reaction. No? H2 plus O2 is giving H2A. That is a combustion reaction. So that is correct. Mercury cell does not involve any ion in the solution. Okay, so that is correct. These are the options. Correct. Next. Lead storage battery. During rechargeable of batteries, right? PbSO4 and anode is converted into PbO2. Okay, this is exactly we are doing in a reverse way, right? Reverse way that is correct because in reverse way PbSO4 is present that will convert back into PbO2. On anode it is converted. That is correct. Okay, this is also important. Everybody, please look at this. See, there were two reactions I wrote. One is Pb plus SO4 2 minus becoming PbSO4 plus 2 electrons. This was the original anode. Okay, this was the original anode. Clear? This was the original anode. And PbO2 plus SO4 2 minus is giving PbSO4 plus 4H plus. That will give you H2. Okay, this is the cathode which we learned, plus 4 electrons also, plus 2 electrons also. Okay, now notice this one. If you are making this into the reverse part, now if this is reverse part here, if it is a reverse part, the cathode will become anode now. And anode now will become cathode because you have to, this PbSO4 is accepting electrons to convert it to Pb. So anode's definition comes with the fact when it is, cathode's definition comes with the fact when it is accepting electrons. So therefore, now this will become a cathode in rechargeable form and this will become anode in the rechargeable form. Okay. So that's why this A is an important option. It's a very good question. Okay. Check. Next. Yeah. Oh, sorry. We have other options to choose. During the charging of battery, PbSO4 on cathode is converted into PbO2. Okay. PbSO4 on cathode is converted into PbO2. PbSO4 is converted into cathode into PbO2. No. Lead storage battery consists of grid of lead uh, consist of grid of lead packed with PbO2 as anode. Okay. No, that is happening at cathode, so that is incorrect. Lead storage battery has 38% solution of sulfuric acid as electrode. That is correct. Okay. Anode is converted into PbO2. Second, just a minute. Sorry. Check it out. During charging of battery, PbSO4 on anode is converting into PbO2. Okay, I think he's still taking this anode as the original one because that is the only match which I can see. Hmm. So yeah, listen. What he's saying originally, whatever that is anode and cathode, he's referring to that. So during charging of battery, PbSO4 on anode is converting into PbO2. PbSO4, which is not at anode, which was originally at cathode, that is converting into PbO2. So he's not asking what is a convention. He's only telling that where it was present. So I think I made that mistake to read it. So he's asking about where it was present. So it is not present at anode. This PbSO4 which is converting into PbO2 was present at cathode. So B is correct there. Okay. So B and D. So only A will come. Okay. Clear everyone? So I hope you got a gist of it. What is the type of questions that were asked 23. But have you noticed something? In 24, the number of questions from fuel cells and battery cells have increased. Batteries have increased. Okay. There used to be hardly one question. In 23, there was, I mean, complete comparing all the sessions, there was only one question. But in 2024, there were a lot of questions asked. Okay. And in 2022, also only one question was asked. Correct. But in 24, a lot of questions were asked. Please check it out. So I think this is something which you need to check properly and read it more carefully in this case. And rest of the type of questions, I want you to go through them once. Okay. Those who have doubts, I'll be back by afternoon. And Delhi students, you can catch up after 4 o'clock today. Okay. I'll just speak to sir once. And based on that, we can discuss. Okay.